The difference quotient, or average rate of change of a function f, is given by this fraction. In our example, we're going to find the difference quotient for f of x equals 2 over x. So f of x plus h, that means that we're going to take this function and we're going to plug in x plus h, which means that I have 2 over x plus h. Because where x is, instead I want to put x plus h. Minus f of x, which is just 2 over x. And that's all going to be over h. Now this one is tricky because to simplify this on top I need a common denominator to get these to be one fraction instead of 2. So we have to ask ourselves, well, what would a common denominator be if I have x plus h and x? Well, it's going to actually end up being x times x plus h. And in order to get that for the first fraction, I need to multiply the top and the bottom by x. For the second one, I'm going to have to multiply by x plus h on the top and the bottom. So you can see now that both of our denominators are x times x plus h. So we can write these numerators together, 2x minus, and let's distribute the minus 2 here. Negative 2 times x is negative 2x. Negative 2 times h is negative 2h. That goes on top. And then on the bottom we've got x times x plus h. And that's actually just our top fraction. We want to end up with h down here. So what can we do? We can say, well, 2x minus 2x goes away. That gives us negative 2h over x times x plus h over h over 1. And then I want to think about h over 1 as though it were a fraction, so that I can flip this fraction up and multiply by the reciprocal. So that means that I'm going to have negative 2h over x times x plus h times 1 over h. And that gives us the h's canceling out, so that I have negative 2 over x times x plus h. And that's all I can do. So now I'm done.